There are many ways to measure angles. Most commonly, we use degrees or radians. You can also use grads or terms, and there's many other ways to measure an angle. Now, in mathematics, we usually stick to radians. And this is because formulas that we've developed are much more elegant when we have radians than when we have degrees. In physics, you'll often use degrees, and this is because it's easier to nicely separate the circle. And because of this, those who are in physics should really know how to convert from degrees to radians. And those who are in math, it would be good to get practice in doing this. Now, there are some special triangles that we have. We'll talk about them shortly, but the special triangles or the special angles can be summarized in the following table. Okay. Now, to convert from degrees to radians or radians to degrees, we have that pi rads or pi radians equals 180 degrees. Okay. So with this, now that we have a way of measuring angles, let's talk about our trigonometry. And the trigonometric functions are based about the unit circle. The unit circle is the circle centered at the origin with a radius of 1. So this radius here is length 1. Okay. Now, here, if xy is a point on the unit circle, then xy equals sine theta cos theta, and theta is the angle between the positive x-axis and the line connecting the point xy to the origin. This angle here. And it's always measured in the positive direction. So positive angles are in the positive direction, whereas in the counterclockwise direction, going up and around from the x positive axis, and negative direction angles are measured in the clockwise direction, going down from the positive axis. With this understanding of sine and cos, we define our remaining trig functions. Secant is 1 divided by cos. Cosecant is 1 divided by sine of x. Tan is sine theta. Let me just write this out, 1 over sine theta. Tan of theta is sine theta over cos theta, and cotan of theta is cosine theta over sine theta. Now, there are some interesting properties for our trigonometric functions. Both sine x and cos x have the domain of minus infinity to infinity, or meaning that they are defined everywhere, but they both have a range from -1 to 1. And this makes sense as the unit circle can be defined for any angle. We can keep going round and round and round, both positive and negative. But the furthest I can ever get away in the x direction or the y direction is 1. Another way of saying this is -1 is less than or equal to sine of x, which is less than or equal to 1. And -1 is less than or equal to cos of x, which is less than or equal to 1. Now, this is used a lot, especially when we're using something called squeeze theorem, which you will learn about when you learn about your trig function. Now, the zeros of the sine function occurs at multiples of pi. So sine of x equals 0 whenever x equals n pi, where n is an element of our integers. Whereas cos of x, we have cos of x equals 0 whenever x equals pi by 2 plus n pi, where n is an element of our integers. Now, both tangent and cotangent have a range of -infinity to infinity. So they can output any number. And cosecant and secant have a range of -infinity to 1 inclusive, unioned with, or to -1, union with 1 to infinity. Each of these functions are periodic. Tangent and cotangent have a period of pi, while sine, cosine, cosecant, and secant have a period 2 pi. Now, the special triangles and commuting the output of the trig functions can be challenging. And there are many ways to do it. And if you've learned a technique that you are super comfortable with, I encourage you, find videos that review that technique and do it that way. We're going to review one specific method, and this specific method will be the method that I will always use whenever solving trig functions. I'm always going to use this technique. If you're confident using another technique, feel free. If you are not confident and want to learn a solid technique, I highly encourage this one, especially because this is the technique I will always be using. Now, this technique uses three things. It uses our cast rule, our principal angle, and what I call SOHCAHTOA. And SOHCAHTOA is a mnemonic to remember our sine, cos, and tan function. So the cast rule tells us which functions output a positive number in which quadrant. In our first quadrant, all the functions are going to be positive. In the second quadrant, sine of x will be positive. In the third quadrant, tan of x will be positive. And in the fourth quadrant, cos of x will be positive. And now, when we have our angles, we have something called a principal angle. And the principal angle is the angle between the closest x-axis and the line that we have. And this is our principal triangle. Okay. And from this principal triangle, we can compute what sine, cos, and tan theta is. And sine theta, sine of this angle, is going to be opposite over hypotenuse. Cos of the angle is adjacent over hypotenuse. And then tan is opposite over adjacent. The remaining trig functions are 1 over f of x, or the reciprocals of some of our base functions. So here, what we're going to practice is we're going to practice these three ideas separately before combining them. First, we're going to look at which quadrants are we positive, or what sign the output will be based on the angle and the trig function. Next, we're going to practice computing the principal angles. Then we're going to practice computing the output of these trig functions using our special triangles. And then finally, we're going to put it all together. So here, we want to determine where theta lies based on the output. So our first angle that we have is cos of theta equals 1/2. So if I go and I draw my quadrant and I go cast, well, cos is going to be positive in these two quadrants. Because it's not 0, it's not on the line, which means as 1/2 is greater than 0, theta lies in quadrant 1 or 4. Now we have tan theta equaling 12. Again, I draw my cast rule, and as 12 is greater than 0, I'm going to pick quadrant 1 and quadrant 3. Theta lies in quadrant 1 or 3. Now, cosecant being -2. Well, I'm going to once again draw a cast, but I'm going to rewrite this. This is 1 over sine theta equals -2. And sine theta, well, sine theta is based on these two quadrants, okay? But as 12 minus 2 is less than 0, it's not where it's positive. It's not positive, it's not where it's positive. So theta is in quadrant 3 or 4. And now we have cotan. Cotan equaling minus 2/3. Again, I'm going to do cast. And here, this equals 1 over tan of theta. The reason why I do that is because this allows me to think of my cast rule. And here, as -2/3 is less than 0, I'm going to pick these two angles, or these two quadrants. Theta is in quadrant 2 or 4. Lovely. We now know where the angles lie. But now we want to compute the principal angles for these different angles. And with computing principal angles, what I like to do is I like to draw a picture of the angle and figure out what I'm subtracting from what. And our principal angle, the key here is principal angle lies in 0 to pi by 2. And it lies in 0 pi by 2, and we achieve it by comparing with multiples of pi. So here, let's draw this first angle. And remember, this is pi, 0, 2 pi, blah, 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 blah. So I'm going to go forward. I'm past pi by 2, which is the top. And I'm not quite at pi, so I'm here, whatever that angle is, right? And I'm going to draw this as my line. And my principal angle is going to be whatever this is. Now, to get it, I always use the technique, the more positive angle minus the less positive angle. So more positive minus less positive. So if we rotate in the clockwise direction, if I go in a clockwise spiral, which I'm going to do in green, if I go in the clockwise direction, it's the first angle I hit, or the first line I hit, minus the second line I hit. And I'm going to be doing axis and line. So my axis minus my line. So here, the axis is going to be, and because the axis is what I hit first, my theta, my principal angle, which we'll call phi, is going to equal pi minus my 3 by 4, minus 3 pi by 4, which equals 4 pi over 4 minus 3 pi by 4, which equals 4 pi minus 3 pi by 4, which equals pi by 4. So my principal angle here is pi by 4. Now what about my next angle? Well, here we're going in the negative direction. So if we think negative direction, 0 minus pi by 2 minus 3 pi by 2. And I'm going to keep working round, go past pi. Now, if I think of 5s, we're just past pi, but we're not quite to minus 3 pi by 2. And this is going to be my terminal arm. It's going to be here. That was terrible. Let's try that again. This is going to be my terminal arm. So if I think I'm going to be doing minus pi, my phi equals minus pi minus my minus 7 pi by 5, which equals minus pi plus 7 pi by 5, which equals minus 5 pi by 5 plus 7 pi by 5, which equals minus 5 pi plus 7 pi by 5, which equals 2 pi by 5. And that is my principal angle. We've got 2 more principal angles. And I'm actually going to leave these as exercises. And I want you to show or convince to yourself that this is going to be 2 pi by 7. And this is going to be 2 pi by 9.